If warm air rises and cold air sinks, then why is it so cold up in the mountains? Today is day 7 of learning something new every day about the world around us and sharing it with you guys. And today we learned, given the common knowledge that warm air rises, why it's so cold up in the mountains and temperature profiles seem to consistently show lower temperatures in higher altitudes. The thing is, warm air does rise. It's just met with regions of lower pressure. In fact, with every 1,000 meters of increased elevation, there's a reduction of pressure by about 10 kilopascals. So as a warm pocket of air rises into these lower pressure regions, it tends to expand, which is a natural tendency as condensed particles have more pressure. And as this pocket of air expands from a condensed higher pressure form into the lower pressure surroundings, it cools down. Why? Because the air has to do work to expand, and the source of energy it gets for that work is the thermal energy from the heat within it. And so due to the first law of thermodynamics, the thermal energy from the warm gas, when it expands, is converted to kinetic energy used for its expansion, and thus the air cools down. And as a general rule of thumb, in areas of high altitude, the air molecules that are spread apart are less capable of absorbing and retaining heat that the sun radiates onto our Earth. And thus, these high altitude areas stay at a lower temperature profile. If you enjoyed this video, follow along for our learning journey.